leaving off where we left off. Hopefully you've had a chance now to practice with your spaghetti noodles and figure these out. So, the next one. I didn't use a protractor on the first one because it didn't actually make a triangle. So the next one, we have 2, 5, and 7. So here is 2, 5, and let's see, 7. Okay, if you do 2, 5, and 7, these two numbers make exactly the same length, if I had measured these exact. So 2, 5, and 7, although spaghetti noodles are a little flat, a little thicker than like a line would be, for this one I would draw a picture like 2 and 5, so I'll say 2 and 5, and then this would represent 7, because 2 and 5 is 7. In order to have a triangle, you need to have a little bit bigger, or they won't ever, if they're too small, they don't reach. If they're exact same size, they can't be. But on this one, 2, 6, and 7, then we can create a triangle. Alright, so if you look at this picture, this one comes out to, I'll just put S for smallest. This would be my medium, and this would be my large angle. Now when I did it, it was roughly like 15 degrees, about 60 degrees, and about 105 degrees. But if you don't have a protractor, you can at least see. Okay, 5, 6, and 7 looks more like those are all about the same size, so it almost looks like an equilateral triangle. It's just a little bit different. This is 5, we'll say 6 and 7. That's about what I would say. So looking at that, this is the small angle, the medium angle, and the large angle. Could you make a triangle with the first two tries? And on that, I would say no. I could not make a triangle with the first two tries, and here's the reason. Because on number 1, we could say something like 2, 1 and 2, or two sides weren't long enough to reach. On number 2, the two sides equaled the third side. Or you could say it was the same length. Okay, so what about the next two? Could you make a triangle in the last two? Yes. So now we have to look at why did it work with these numbers and not the other numbers. So think about if 2 and 5 equaled 7, they were the exact same length. But 2 and 6, well, that makes 8. And how does that compare to the 7? So 2 and 6, 8's bigger than 7. So yes, or here 5 and 6 is 11, so that would be bigger than 7. So yes, the two smaller sides sum to greater than the third side. Or you can say add up. Alright, so looking back at angles 3 and 4, what do you notice about the smallest angle and smallest side? What do you notice about the largest angle and largest side? Okay, so look at where it's located. You have smallest side, smallest angle, smallest side. Largest angle, largest side. Down here, smallest angle, smallest side. Largest angle, largest side. So if you notice the location, the key word from the last page of notes that we did is they are opposite each other. So the smallest side is opposite the smallest angle. Which goes with, think about in a right triangle, 90-degree angles are your biggest angle and the hypotenuse is your longest side. So in a right triangle, this is the largest angle and this is the longest side. So they are opposite each other. So it works on all of them. Smallest angle matches opposite smallest side, and so forth. Okay, let's look at our last page. So some conclusions we can draw from our little spaghetti experiment. Write a rule about the lengths of sides of triangles that you got out of this experiment. So in general, how do I know if I give you three numbers, how will you know that it's going to make a triangle? So the rule would be to add the two smaller sides to see if it is greater than the third side. Another way we wrote it on the other side is the two smaller sides need to sum to greater than the other side. So I'm going to say side 1 plus side 2 needs to be greater than side 3. The two smaller ones need to add up to bigger than the third one. Not equal to, because that makes a straight line. It has to be greater than that. The rule that's always true about relationships between angles and sides is the smallest angle is opposite the smallest side, or vice versa. You could do it the other way. The smallest side is opposite the smallest angle, or largest. And I'm just going to put ETC because that represents everything. So like the medium angles across are opposite the medium side, large and large. Okay, so Pythagorean theorem triples. This is something you'll do later in trig, which I'm assuming most of you guys will probably take trig. There are three numbers that make the Pythagorean theorem true. So what I mean by true is if we know that Pythagorean theorem is a squared plus b squared equals c squared, the two sides need to add up when you square them and be equal to the third side squared. So a common one that you will see would be 3, 4, 5. If you want to see if that works, that would be 3 squared plus 4 squared. Does that equal 5 squared? And remember, the biggest number is always the one at the end, because that's your longest side. So that would be 9 plus 16. That does equal 25. So 3, 4, 5 make a right triangle. You could brainstorm these, but for time's sake on the video, I'm just going to go ahead and give you the next one. A common one would be 5, 12, and 13. And if you want to see it worked out, 5 squared plus 12 squared equals 13 squared. It would be 25 plus 144 equals 169. So these are called Pythagorean triples. They're three numbers that make the Pythagorean theorem true, that 25 plus 144 is 169. So I'm going to list the four most common triples. I would say 7, 24, 25, and 8, 15, 17. Those are probably the most common ones that people memorize, but again, it's just something you'll see later. Since we're talking about Pythagorean theorem today, I'd throw that out there. These are 3 numbers that go into Pythagorean theorem, and it works. No decimals. Alright, the converse of Pythagorean theorem is kind of using Pythagorean theorem, but the word converse means instead of starting with a squared and b squared, you switch the order. So, it would be if c squared is less than a squared plus b squared, then it's going to tell you that it's an acute triangle. Okay? If c squared is equal to a squared plus b squared, well, that looks just like this one. So if it's equal to, we know that's a right triangle. If the c squared is greater than a squared plus b squared, then we know it's an obtuse. So if that third side is less than the other two when you square them, it's acute. If that third side is greater than the other two when you square them, it's obtuse. Okay, so again, it's weird because converse means you have to start with the c instead of the a's and b's. Alright, so we're going to look at this. You always want to make your biggest number is going to be your c. Okay, so we start with the c. First thing I do before I even do that, it says given the side lengths, determine if the triangle is acute, right, obtuse, or not a triangle. So let's determine if it's a triangle first. If it's not a triangle, there's no point of moving forward. So determine if it's a triangle. So triangle question mark. This is what we decided with the spaghetti noodles. The two smaller numbers, 7 plus 14, needs to be greater than 16. Well, that gives me 21 is greater than 16, so yes, it is a triangle. So now we need to do this and decide what kind of triangle it is. So I know it's a triangle. I can cross that one off. And I'm just going to leave a blank here because I don't know what it's going to be yet. No, I probably will have to look this up. 16 squares, not one I do a lot. That's 256 blank 49 plus 196. So how does 256 compare to 245? Okay, well, 256, the c is greater than 245, so that makes the c obtuse triangle. So determine if it's a triangle using just this. Do the two numbers add up bigger than the third side? Once you determine it is a triangle, then you decide if it's acute, right, or obtuse based on those converse things. So just double check. 11 plus 10 is greater than 14. So 21 is greater than 14, yes. If it wasn't, then you would just check mark not a triangle and be done. But 21 is bigger, so we need to go ahead and keep going. Remember, this is your C. You start with your C. So I'm squaring them. Now I'm going to add them together. So on this one, 196 is less than 221, so that would be an acute triangle. If they ever come out exactly the same, then you know it's a right triangle. And if it doesn't pass the triangle test to begin with, you just check not a triangle and you can be done. You don't have to do this. You can't classify it as a triangle if it's not a triangle. So if this is no, that's where you stop. If it's yes, then you figure out what kind of triangle is it.